easier for you to figure out. Great. Great. So we'll go ahead and get our July session kicked off. We have the great honor today of having Ed Weber speak on data transformation. And so Mr. Weber is a data transformation strategist for Salesforce public sector. He's a passion for digital transformation and data-driven making decisions. He spent more than 30 years of experience, 60 if you include mine, 30 years of experience in the software industry, concentrating on data application development and analytics. In his current role, he focuses on developing analytic solutions for public sector clients and employing visualizations and predictive technologies. He's co-authored 2 books and numerous articles in information technology, and is an experienced presenter, having spoken at hundreds of events across the globe. And we have the great honor of having him with us today. So with that, I will stop sharing and let you kick it off there, Mr. Weber. And we'll be, I did want to open up the chat as well. So I'll be monitoring the chat for questions that come in. Anything I can answer right away, I'll do so. And the rest, I don't know, sir, if you wanted to wait for questions to the end or answer them as they come in.
No, I think we have a small enough crowd. I think we can probably handle questions as we go along. So if you see something looks pertinent to the topic, please chime in there. It's a little boring just hearing me talk for 20 minutes or 30 minutes or whatever.
Thank you so much.
So that'd be good. All right. Hey, thank you everyone for coming. I appreciate your time. So we're going to talk a little bit about analytics and the AI maturity curve, which is kind of a broad topic, a pretty big topic these days. So I'm going to sort of break it down a little bit as we go through here. And I'm going to start off just by, I'll give you a quick overview of what we're going to do. We're going to talk about what this kind of is in general, go through some details, talk about how hard it is oftentimes to start in this area, and then focus a little bit on the people and data side of things, which oftentimes is ignored in this kind of transformational effort. And so how do we sort of get there at the end? So I'll start it off by sort of just giving a basic definition. Analytics maturity represents an organization's level of advancement in utilizing analytics to drive insights, make data-driven decisions, and achieve strategic objectives, which is a great sentence. In fact, I know it's a great sentence. I asked an expert what analytics maturity actually was and said, give it to me in a sentence, and this is what I got. This is so saith ChatGPT. So already I'm at a high level of analytics maturity just because I could ask a question in ChatGPT, right? That's kind of one of the higher levels of analytics maturity, supposedly, which we'll find out really isn't anymore. But just this idea of analytics is sort of pervasive everywhere now today. And we want to make sure we understand where it's valuable, where it's not, where the limitations are, and so on as we go forward. And I'll talk a little bit about this idea of what I call climbing the mountain, getting to the top of the maturity curve. And we've got some characters down there. If it was me, I probably would have had the goat at the front, but whatever. We'll go forward here and talk about analytics at the basic level, which is for most organizations and most leadership over the history of humanity, we've used the most complex neural network that we've ever run across, and that's the human brain. And the human brain usually relies oftentimes on intuition or experience, or sometimes we call it swag, scientific wild something guess. And that is often the way leadership and individuals have acted and generally have acted over the course of history. And even today, that's sometimes the case in a lot of organizations. We rely significantly on our ability to take our experience, all we've learned, and we don't want to discount that. And that's actually very important, especially when it comes to analytics. We don't want to discount the experience and the intuitions that people have about the workplace they're working in. And so at the sort of the bottom of the curve, we have something we think of as descriptive analytics, which essentially is answering the question, what happened? It's really backward looking at data that we have available and trying to decipher what actually happened in the past. Most of the time, descriptive analytics today is being done with analytics tools that use visualizations of some type, whether it's pie charts, bar charts, curves, and so on. People tend to take in analytics more effectively. Most people, not all people, but most people take in analytics effectively using visual cues like dashboards and things like that. Beyond sort of the what happened, we get to the next section, which is diagnostic. This is really asking the question of why it happened. So we might have a what happened, like my house sold for a certain amount of money. Let's say it was $100,000. I hope it's worth more than that, but let's say it's $100,000. I might want to ask, why did that happen? Why was my neighbor's house sold for more than my house was? And I can start looking at the data to try to understand, and I might look and see, oh, they have a lot more square footage than I do, so I understand a little bit why that happened potentially. But usually these questions become a lot more complicated than kind of just a one-off relationship between sale price and square footage in houses, for example. They can have very complex relationships that we don't oftentimes think of. I used to do a little work with something called hedonic pricing in housing, and looking at why houses sell for different prices. And you can actually use sort of advanced statistical capabilities to go through and look and see how much the paint color on a house might change the price of a house, or how much having an extra bathroom matters, and so on, and build those all into a more complex model to really get an understanding of why houses sell for different prices. And the same is true for most things that we see in the workplace today. The problem is oftentimes we don't have as much great data as we often have with things that are in the public, like housing and so on. So as we move up this chain, the next thing is predictive. I understand what happened. I understand maybe why it happened, or have some inkling of why it happened. I now want to sort of look at the future and say, what's likely to happen? If I put a house for sale today, what's the likely price I'm going to get for that house based on my diagnostic capabilities that I've used in the past? For most organizations, predictive analytics is used very sparingly today. I think as we go forward, we're going to see more and more of that. Predictive analytics can be very pinpoint and accurate around a particular item, or it can be very broad. For example, I worked with a few different people around how organizations try to predict what their revenue is going to be for a given year. And that's a really complex relationship to try to figure that kind of thing out, versus whether or not a batter is going to get a hit in a baseball game. That's kind of drilled into everybody when they watch baseball. They know what the odds are, right? And so predictive is really guessing what will happen. But oftentimes, in fact, almost always, it's not 100% accurate. It's very rare that you get to high levels of high quality prediction. At the next level up, we go into something called prescriptive analytics, which is what should I do? This can take very simplistic forms and can take very complex forms. And I'll go with a simplistic one first, and then go with a more complex one. I'll stick with my housing analogy here. What should I do to raise the price of my house if I'm trying to sell my house? And I can look at different options, like what will happen if I add a pool to it, or what will happen if I add a deck, or what will happen if I remodel the kitchen. And I can find out based on diagnostic analytics maybe what the best choice might be and make that choice. For example, in those examples, I'd probably put in a remodeled kitchen. That's going to have the best effect on my housing price. But prescriptive analytics really comes out of something called operations research, where organizations look at just huge amounts of data and try to figure out, not just for one decision, but for many decisions, what the best plan of action is. A sort of simple example, I'll look at a sports league like the NFL, for example. Every year they have to create a schedule, and the schedule is fairly complex because it involves 32 teams all having to play each 17 games. And how do I make the schedule fair? How do I generate the most TV revenue? There's lots of different things they care about. And they run these prescriptive models to try to figure out what the best outcome is. Not one of those different things they care about, for what's the one that maximizes all of them as much as I can. And usually not one is the winner. Usually one of the things is the loser. But in most cases, they come up with a schedule. Obviously, they do that every year. A more complex one is Amazon. If you look at Amazon's delivery schedule, they deliver about 1.5 million packages every single day in North America. That's a lot of people. 1 out of every 20 houses on your block gets a package every day, basically. And how they actually decide how they're going to package up, get the information, get the good, whatever it is, let's say the item, we'll just call it the item here. They get the item off the shelf out of which warehouse, in which location, what does it go on, what kind of truck, where does it go, does it fly, does it take a train, do they drive it in a truck, what distribution center does it go to, all these factors for each package, and there's 1.6 million of them every single day. They have a vested interest in optimizing that process so that they know that they get the most on-time performance by taking all the different variables and getting those all out to their customers, and yet still they probably have 5 or 6% late every time they do deliveries. So it's not a perfect world, but they do the best they can with really complex situations. That's sort of the high end of prescriptive analytics that we see today. Beyond that, we get into something we think of as cognitive analytics, which includes a lot of different things in that bucket, including what I just showed you, ChatGPT right there, but other things, large language models, generative AI, and things like that. All of these fall into that larger bucket of cognitive analytics, and that's usually at the high end, which is helping us answer questions that we just really don't have an answer to. It's not taking necessarily data we have and doing something we can easily do ourselves, but really trying to figure things out that we can't do very easily ourselves using the power of the machine. And as we sort of progress up this curve, We move from really the basic reactive, I'm looking backward in many ways, to proactive, doing predictive and prescriptive, optimization and foresight, and then finally up to the AI levels with large language models, GPT, generative AI, and so on. This is the goal of most organizations, to get to that genius level at the top. But the reality is most organizations don't take this type of path. The path is oftentimes scattered with different efforts across different people, across different parts of the organization. And it doesn't happen in a very clean way in most cases, as it probably shouldn't either, because there's a lot of experimentation that goes on with analytics and AI as we go forward. So first I'm going to introduce is the concept that we're not as smart as we think we are oftentimes. There's something called the Dunning-Kruger effect. Some of you may be familiar with this. Essentially, it's the studies of people when they try to take on a new set of knowledge and they become competent at something. And there's this classic thing called the Dunning-Kruger effect, where people learn a little bit and they think they know a ton. I was just able to use ChatGPT to generate a sentence that I used in my presentation. I know AI like the back of my hand now, right? That's obviously not true, but it was so easy to do the first thing that I think my confidence level is very high, even though my competence is low. And in the world of Dunning-Kruger, this is known as the peak of Mount Stupid, where you really think you know a lot, but you don't really know very much at all. And then once I dive into AI and try to learn a little bit more, suddenly I realize I don't know anything about this. I just was using the easiest thing possible. And now I've gone into the valley of despair and I realize how much I have to learn. In many ways, traveling any information pathway like this is like building a jigsaw puzzle from the inside out. You start with one piece, it seems very easy. I just got to add 4 pieces and I'm done. But the reality is with every piece you add, the puzzle gets larger and larger and you generally don't find the edges very quickly. And so you fall into that valley of despair quickly. You start to learn more and more. You start to become enlightened about what's going on. You learn what you don't know, which is really critical to this, and eventually lead to the plateau of sustainability where you've learned really what you should have thought you knew early, but now you know it late with a lot of experience and a lot of knowledge. And we see this with analytics. Organizations the tools that are available today are incredibly easy to use, and it makes it seem very easy to start using them right away and start getting the results. And sometimes the results are very good, and sometimes they're very misleading. So you don't often have to be an expert to spot issues with misleading data. And I pulled some information from a kind of an interesting guy at Harvard, a professor at Harvard, did some stuff on what everybody calls spurious relationships. And here's an example of one. People who drown after falling out of a fishing boat is highly correlated with the marriage rate in Kentucky. So if you didn't know anything about this topic at all, you might think there's some relationship here because obviously the lines are very closely correlated. But the reality is obviously that that's not the case. You know, I'd be encouraging people not to get married in Kentucky, I guess, because I don't want people drowning. So obviously that's a dumb one, right? If we go to the next one, the divorce rate in Maine correlates highly with per capita consumption of margarine. Again, doesn't make a lot of sense, but obviously there's a high correlation between these two things. And people who don't know these areas quickly identify that these are problems, right? My favorite one, per capita consumption of mozzarella cheese correlates highly with civil engineering doctorates. And I actually talked to an expert about this. My wife is a graduate in civil engineering, and she told me that's not true. It's not mozzarella, it's Parmesan. So this is obviously not correct. So we had a little bit of knowledge there beyond the statistic itself. But if we get to something that's actually important, like do smaller class sizes increase student proficiency? Are students able to read better if they have a smaller class, a better student to teacher ratio? This is something that came out in data in the late 1990s, early 2000s, looking at data across the country and found that there is a relationship between student class size and student teacher ratio and their proficiency of students. The smaller the classes, the more proficient students tended to be. And a lot of money got poured into this idea of actually reducing the size of classes to make this happen. But it was a very simple metric, very what I'll call high granular metric. And when they actually talked to experts about teaching and what was going on actually in the classrooms, they started doing further studies to try to look at, was it really the size of the classroom or was it something else? And it turns out to some extent, it is the size of the classroom, but it's also how teachers change the way they teach when they have smaller classes. Some teachers taught the same way when they had a big class versus a small class, and their student performance didn't change at all. Other teachers changed the way they taught, given the fact that they could spend more attention on certain students or other topics, and it actually increased the student proficiency. And so knowing the basic the relationship here wasn't enough, and yet people jumped to a conclusion, right? There was something similar when my children were first being born about having you listen to Mozart when the kids were young, and that would make them smarter. And that turned out to be completely false as well, but there was some weird spurious relationship there. So we have to be careful for things that sound like they're true, but when an expert actually looks at it, we find out that it's really not true, or there's something not quite right about it. And even if we go to the lowest level of maturity, the decision making of how we do things can be somewhat complex. So let's say we stick with just something called descriptive analytics, which is usually just visualizations. And I'm someone who wants to create a visualization. Does the type of data that I'm using always define what the visualization should be? And so there's this commonly used decision-making chart, which looks complicated, but it lets you decide based on what data you're using, what kind of visualization may best represent that data. And this is one that's pretty well known. I've seen this in various forms several hundred times, and it's pretty useful, but it assumes something that you know which data is important and which data is going to go in the right places. And oftentimes that may not be true. And oftentimes you want to focus instead not on what the data is that you're holding in your hand, but instead on how does it affect the question I want answered? Really, you want to focus on the question, not necessarily on the data. And sometimes you want to have sort of a decision tree where someone could ask you questions and you could go step by step and try to figure out what the best decision making is, or what the best visualization is based on the decision you're trying to make. And again, I reached out to ChatGPT and told it to give me a decision tree for visualization, and this is what it came up with. So this is a pretty common one that you could find in a lot of places on the web. So how you think about it often affects how you proceed. These visualizations cannot just be simple like pie charts and bar charts and so on. They can be pretty robust. Today's visualization tools let you create incredibly complex visuals that people can use to communicate all sorts of ideas. And that's really what a lot of this is about when it comes to descriptive analytics. Here's an example of someone creating an intra-European migration map that gives people information about where people are coming from, what countries to other countries within Europe. Or something like this one, how global art is traded around the world, inbound and outbound to different countries, things like sculptures, antiques, and so on. Or one looking at generations and how big the cohorts are at different ages and the different statistics about them. These are all things that people who are not necessarily high technology people can do now with the visualization tools and other tools we have available today. So the landing spot for the first step is actually pretty broad today. It's just a question of, do you know your information well enough to use that first step to communicate what you want? And I would argue sometimes people go overboard with these things and they create such visualizations that are so complicated, a layperson can't look at them and even get anything out of them, because only an expert could maybe look at it and figure it out. Something beyond sort of how high up on the curve you are, how high in the mountain are you, is something I like to think of as the breadth of maturity. Individuals and organizations have different breadths of maturity. So not just do you have something that's at the AI level in your organization, but maybe ask a question like, how many high-level analytic services are delivered by technologist departments in an organization? Basically, how many parts of the organization have high-level analytics being put into use? That's one way of thinking about the breadth within an organization. Or how mature various departments are in creating their own application of analytics. So this is more than just department level. This is down to individuals in some ways, or at least in department level. And then maybe how mature individuals across each department at leveraging and building analytics. This may be something that's very important for organizations to get to that level of maturity, depending on the type of organization. And I'm going to argue in a minute that it actually is very important. That third bullet is critical. And then last, how much are analytics and insights trusted and used across departments within an organization? And I highlight trusted and used in large measure because creating analytics is often fairly easy for a person who knows about the data and knows about what they're trying to do. But getting people to trust and use those analytics is oftentimes a big challenge. Several years ago, I had the lucky happenstance of sitting next to someone who was the chief economist at one of the largest software companies in the world. And we had a good conversation about what his team was doing within the organization. And one of the things they did was predicted at the beginning of a quarter what the quarterly revenue would be for the next quarter. And they were getting it within hundredths of a percentage point to being correct of exactly what the revenue was going to be in the next 3 months, which seemed like magic to me that they could, in a large organization like that, get that level of complexity. And the reality was they proved it over and over again, quarter by quarter, they were getting it correct. And I asked him and I said, do your leaders just love what you're doing? I mean, they must listen to you every day. And he said, no, they generally don't. And the reason was and I asked him, and he said they tend to rely on their instincts more, their experience. They think their experience is more important than the insights that we're delivering. And so this idea that they're trusted and actually used, it's not enough to create them. You got to have people that actually trust them and use them in order to have insights actually drive an organization. So here's an example of a chart here I created of the breadth of a particular fictional organization that has several departments associated with it. In this example, the IT organization is using a lot of high-end analytics. They're at the top level of the mountain here. The inspections group, maybe they're doing border inspections on trucks coming across the border or something like that. They use a lot of things like predictive analytics and maybe even prescriptive analytics to decide which trucks they should be searching. HR maybe does a little bit less. They maybe are looking at what's keeping people in the organization. What kind of changes do we make, maybe from a proactive perspective to try to keep people from resigning within the organization or hire people, and so on down the chain. This particular organization has a certain amount of depth, depending if you look at just their highest point, they have a lot of analytics maturity, but I would argue they probably don't because most parts of the organization aren't leveraging it at all. Whereas this organization, the similar organization here, right, has analytics being used across a large portion of the organization across many departments. I would argue this was one that is actually much more mature, even though they all achieve the same highest point. This one has the high point being reached by multiple places, and every other part of the organization is much higher. But this is still at the department level. It doesn't even get down to the individual level within departments, which I think is also fairly critical here. When we survey people, a GovExec surveyed people last year and asked them the question, in 5 years, interpreting and analyzing data and sharing insights will be essential to my essential function of my job role. 85% of people either agreed or strongly agreed with that, meaning that almost everyone thinks that they should be analyzing data and generating insights that they share across the organization. I would argue that almost very few people in most organizations actually do this today, but most think they should or will be doing it within the next 5 years. If we focus more on sort of the people aspect of this, the graph on the right here has some data from a Forrester research done a couple of years ago across all organizations, not just the government organizations. But employee satisfaction, when they have what we think of as data satisfaction, their ability to use and leverage data within their jobs, is 10 times higher than people that don't have that level of satisfaction. And people are twice as likely to leave their organization if they aren't employing that type of analytics within their job function. And so this isn't just a question of whether organizations themselves are using analytics and reaching the highest levels of data maturity. It's really about the organizations being able to retain talent and have an organization that's moving forward if they don't do it at the individual level. And part of this is because we really want to empower those domain experts. I talked about this a little bit earlier. We want domain experts to be able to be the ones who actually generate our analytics and not just consumers of analytics that are maybe generated by the IT department or the chief data officer, because they're the ones who are going to know whether or not it makes sense or not. If you ask a domain expert and give them some analytics created by someone else, they'll oftentimes poke holes in it right away because they know it doesn't actually represent the real world that they know so well. I'll give you a quick example. I can do this with almost any organization. If I had the data, I could show you that people with larger shoe sizes are promoted more often than people with smaller shoe sizes. Now that sounds stupid, but it's actually true. The problem is if I come to an expert in HR about this, they would laugh me out of the room. If I told you buy everybody clown shoes, right? They would say, no, that's not going to do anything. But they know that there's an underlying reason why that data is actually true. It's not a spurious correlation. It's true for a couple of reasons. One, men are promoted more often than women in most organizations, and they are taller and they have larger shoes, right? And taller men are promoted over shorter men more often in organizations just because they're taller. And people in experience in HR kind of know this, but pulling the wrong data out and trying to show that there's some relationship may indicate an underlying problem, but not the actual problem. And so employing domain experts to create analytics is really critical to organizations moving forward successfully. Data literacy is another big one. Understanding and using data. There's a large swath of our population today in the workforce that don't really have a strong ability to understand and look at data. Show them a bar chart or a pie chart. Oftentimes it's confusing to people. They're not comfortable with looking at data in that way, or giving them raw data is almost impossible in many ways to use. And so we really want to promote data literacy across an organization, and that's critical so that there's common understanding of what metrics mean when we try to share them across an organization. And finally, insight consumption flexibility, I think, is critically important as well. The ability for people to get data and understand data the way they like to see and understand it. And so some people are very comfortable looking at a pie chart and figuring out insights. What's the largest X or something, right? Looking at that. Other people find that very difficult, and they would like to have some type of augmented analytics where key indicators are pointed out on the graphics themselves for them so that they don't have to tease it out by looking at it themselves. Some people prefer entirely narrative analytics, where they get essentially a series of bullets or a paragraph that describes what otherwise you might see in some type of visualization. And if you've ever tried to receive any kind of analytics in a visualization form on a phone, you're probably going to be more comfortable if you see it in a textual format because it's much easier to read just on the eyes themselves. And so that insight consumption flexibility, whether it's the vehicle you're using to consume it or the way that the information is presented, differs from person to person. We want to make sure that we have that type of flexibility in an organization to make sure that everyone who gets an insight can understand the insight to their level of expertise. I'm going to move and talk a little bit about data, and some of you are probably not data people, but I'm going to talk about it kind of at a high level. Traditionally, which is what we're seeing on the left side, is what organizations did with data and analytics. They would start with all of the data that they had in all their underlying systems, their structured data. They would perform a process known as ETL, extract, transform, and load, pull that data out, and put it into what we commonly know as a data warehouse. Sometimes you'll see the term enterprise data warehouse. When Gartner studies this process, they actually find that about 85% of data warehouse projects actually fail, which is not a good success rate. I wouldn't let this person bat on my baseball team if they were going to strike out 85% of the time. But if they do succeed, they can then create what's called reporting metadata, which maps real world terms to sort of field names, which are oftentimes pretty obscure, and then allows people in the business world to consume that information through reports and graphs and charts and things like that. But this legacy approach is really about developers putting together the content and then delivering out to the end user community. And the business itself doesn't have a lot of say other than giving feedback as to what they'd like to see. And the process is fairly slow to make changes as you go forward. In a more mature architecture, you see something a lot different. You're pulling data from a lot of sources, both internally and externally. You're creating what it's called a common platform with purpose-built data sets designed for particular areas of the business. And then people at the line of business actually using the last line to prepare data for themselves and employing themselves analytics, reporting, data science, and machine learning. And as the technology improves and continues to improve, this becomes easier and easier for people in the line of business to do. This allows the experts in the field to create the actual analytics and verify them before they're spread throughout the organization, and lets IT do what it does best, which is organize data and bring that data to the front. But also it creates a new critical role for the IT organization as well, which is not just the data management on the left side here, but also content management. As people build new analytic insights, they're in charge of making sure the right people see the content, that you're not sharing proprietary information outside the organization or within the organization where people aren't supposed to see it. So IT and what I would call an analytics center of excellence would make sure that all of this stuff is done correctly, but they're not actually creating most of the content, with the exception of maybe some high-end predictive analytic models or things like that, that maybe someone at the line of business doesn't have the ability to do. So again, we're going from a sort of a feed you kind of process to really a self-service process where people in the line of business who can learn analytics and actually can employ it and be trusted in doing so creates a much better environment for the organization. Do we have any questions so far, Daniel?
No, none in the chat.
Okay, great. All right. One thing I often talk about with our customers is what's that called insight transformation pathways. Is how does an organization move from being sort of a top-down analytics organization to being more transformative? And I often like to start at the bottom-up side, which is I've been talking about today somewhat significantly, which is making sure people who are at the domain level and experts are empowered early on in the process, because what they create is more trusted than anybody else's analytics. In the center here, the technological transformation, that's generally the IT organization. They want to modernize their data architecture for a more distributed model. They want to make sure that they employ the best platform as possible and make sure those are monitored and kept running successfully. But at the top, I think is also something very critical here. And I've had this conversation with a number of executives across the federal government. First of all, most executives don't really want to be data driven. And when I say that, what I mean is they don't want, when I have an executive, they don't ever say, hey, you know what, I need to make a decision. Somebody get me an Oracle database. Right? That's not what they think of when it's data, right? They really want insights. They want to be insight driven, which means they want to get information that's based on data, but that's been processed by someone who understands it and can deliver to me something that actually can allow me to make a decision based on that data. And that's really where those experts come in at the bottom. And so for this to work successfully, there has to be a desire at the top of the organization to actually be an insight-driven organization and not have everything happen at the bottom of the organization, because oftentimes that transformation will never occur. Because again, as the example I gave with the economist at a large software company, if leaders want to rely on gut instinct and intuition all the time, it'll never work for the entire organization. They'll never reach the top of the mountain of the AI transformation. And so in summary, the analytics maturity curve is oftentimes depicted as a straight line, like it is here in this example. It's easier to draw a straight line for me. But in most cases, it's a very curvy line. It's not a line that goes straight up. It's oftentimes depicted as a line that's sort of asymptotic, where it goes from low and then it swoops up really fast at the end. I would say that is very rare that would ever happen, that you get faster and faster at it as you go along. Usually the first part is very quick, and then as you move to the higher levels, it slows down to some extent because less people have the ability to make that happen. But the goal is to obviously move up the food chain, and with the technologies available today, we now have sort of blurred the lines of where things like cognitive and predictive come in, because those technologies have now been inserted back into the descriptive layers and the diagnostic layers. And so people don't have to be experts. The tools will often do a lot of the work for them. And so this traditional analytics maturity curve isn't a straight line. Oftentimes you'll start with descriptive and then jump right into cognitive, because the tool that you use has the capability to do that. So you'll see as we go forward in the market today, and as we work forward in the next several years, cognitive will land more and more in different parts within the different places in the maturity curve. And we're going to see that make it easier and easier for people who are domain experts to employ these technologies in order to give insight to the whole organization. And with that, I'm going to pause for questions.
Ed, I might have one.
Yep.
I definitely agree, and I can't come off my video for some reason. There we go. I definitely agree that, going up that learning curve is important, and that, expanding the knowledge of how these tools work throughout the organization is something we should do. But how do we actually do that in a federal space, right? You push out another mandatory training? Doesn't seem like a super effective way to do it. So do you have recommendations on how to actually go about expanding the knowledge without sort of forcing people to take trainings they're going to skip through?
Yeah, I mean, I think the good news to some extent, and I'm going to go back to this study here. 85% of people believe they're going to do this who work in the federal space today. So the good news is people anticipate that their job function is going to require this to some level. So that's actually, the ground is fertile for this. Let's just say it that way. But it does take a lot of leadership to make this happen. It also takes a technology organization that thinks that it needs to change its role from sort of the left side here, the more traditional methodology, to a more self-service methodology. And that's oftentimes a very big challenge. And you have to sort of understand the players. And another part of this too is there's a lot of what I'll call data propriety within most organizations, especially in public sector organizations, where sharing information is oftentimes seen as potentially problematic because you don't want to share, let's say, voter data or constituent data or things like that across lines within an organization. So you really have to have a strong data governance process in place as well to make sure people can access data that they need without having it completely be shut down. So I'll go back to this, which is it has to be attacked across all three pathways. You have to have the leadership that wants it. We know the bottom up kind of wants it, but they don't have the tools and or the data to make create those analytics today. and we need to have the IT or technological group create the mechanism or the framework so that it can happen across the organization. So we really need to attack it all three ways.
Is there any?
Does that answer your question?
It does, in fact. Do you know if there's any work at the political level, the congressional level? Obviously, this would take a lot of time and money and effort, particularly in large, complex organizations. You know, thinking HHSs, DOJs, DHS, right? Very big organization with lots of moving parts. Have you heard, or are you aware of any efforts on the political side that might make this transition easier?
Obviously, the federal government has a federal data strategy today. It's been in place, I'm going to say 5 or 6 years now. There are efforts that are more, I would say, fits and starts than there have in the past. I've not heard of anything at the legislative level to say, hey, agencies must do this. In fact, I'm not sure even agencies oftentimes want to do this at this point, only because they're short on staff. They're difficult to get the day job done, right? They're having trouble getting their day job done. And this is an extra layer of effort that has to go in that pays off a lot down the road. But when you don't have money today, it's hard to invest in tomorrow.
That's fair. Thank you. Anyone else have any questions? I've asked a couple here. There's nothing new in the chat that I see. I imagine at this point you can take yourselves off mute and you could probably ask your question better than I can read it, given my reading skills earlier. Something else we could think through. Ed, do you have any questions for the group? Are there polling perhaps that we could help answer for you in our limited capacity on the subject?
No, I don't want to try to poll everybody. That's really challenging, I think, at this point. And I hadn't thought of any questions, frankly. So that would be challenging for me.
No
I do want to say if anybody wants to connect with me and have questions down the road, please, you can email me, or if you've got your phone and it has LinkedIn on it, you could just scan that QR code. It'll take you right to my LinkedIn profile and you can connect to me.
Great.
So
Well, thank you
oftentimes
so
people
much.
don't ask a question in a public forum, but they'll be happy to email you or text you about it.
Wonderful. All right. Well, thank
All right.
you very much. I'm going to take the slides back.
All right. Thank you.
Figure out how. There we go. Great. So just to wrap, thank you very much, Ed, for your time today. I know there's a lot of subject to get through, so I appreciate you helping educate us on how all this could work, particularly the investment needed to expand our thinking of how we use the analytics we have in front of us, as well as sort of go up that learning curve to use the predictive analytics of tomorrow, right? For the good of the group, I wanted to looks like there are some chats, other thank yous. There's no August meeting. We tend to have a summer recess. So if you have a recurring invite, don't show up. I won't be here. But we do have our next scheduled meeting on September 12th. In the meantime, our legacy system modernization report is out there and being worked as an active project. ELC, we're beginning to ramp up on some ELC activities, and then the leadership group is working on our annual work plan based on the discussion we had at our business meeting last month. So with that, I think we're at a close. If anyone has any questions, comments, concerns, I'll stay on the line a while longer. If not, thank you all, and thank you, Mr. Weber.
Thanks, everybody. Appreciate you being here.